devoted to restoring and coming back to what systems we had. Now, nature has no waste in it. This is rather incredible when we talk to children and we say, do you realize that how come nature does not have any waste? And that is because of the circularity of it, where every output of every one system goes into another. It's humans who create this waste, and which is why we need to learn from nature and imitate that to some extent in what we do. This is where the circular economy becomes very critical to what we are doing in India. There was a lot of talk about what we can do, and I started by saying how we have to tweak this model to our own country. We were looking, for instance, at recycling of plastic waste. And you have a whole community which has traditionally done this. And which is an informal sector, we have a very large informal sector. If you don't take these into account and just look at it from a point of view of a mechanical thing, then you will suddenly have a major social and economic impact of people going out of business. We also have different types of densities. We also have our own ability to do jugaad. We find solutions to problems in very different ways from other countries. So what is really required is finally not only industry, but every community member, every individual to really change the way they see the environment and change the way they see their own role in it. Which is why in '84, when the Ministry of Environment was being formed, it was felt that we need an organization which really looks at creating public awareness and education for environment and for this. We've been working very closely with industry, and we find that the solutions are coming from industry, but they are not necessarily being transferred or not necessarily being scaled up at the rates they are. And many times you have policies which affect what you can do and what other people can do. We are going and finding models within the industrial estate for finding how you can do things better synergistically, where one industry is affluent and another one's match, and we can do something in a better way. The industry, industrial associations and groups like yourselves and the plastic industry really needs to say how we will do this. The use of single-use plastic is something which we have discussed with Samir, you and several others as to how we can make people feel it. But it's suddenly when COVID came, we had a huge outburst of the need for single-use plastic, and we need to find ways in which we can reuse this. Today you have Padma Shri Vasudevan on the panel, and he has got one innovative way in which he is being able to use it. We have with the United Nations Environment Program a program called Tide Turners, plastic tide turners, in which over 100,000 young people in India are today, even in COVID times, are acting locally. They are acting in their communities. They are doing things to act wisely and to save plastic. It's been very difficult to, for instance, talk to people that it's not plastic which is bad, but it's the way you dispose it, the way you use it. And it ultimately comes back to their lifestyle and behavioral change. So we are really looking at ways in which we can do that, ways we can get people to change behaviorally. Education and communication is a very important part of it. We've seen how behavioral changes happened during the COVID times. Things which we never imagined we would do, we are doing it right now. And this is how we want to go forward. So I can see me now. I can wish this conference all well. I think some of the ideas which have come up really need to go into the Indian system, and I think we can really make a difference, make a change, if we can really do that and go towards a more circular economy. Thank you, Samir.
Thank you, Doc. Thank you, sir. Thank you. Any questions?
Okay. Yeah, we can move on to our next speaker. So then we will take that.
There was one question here which was, if the logic of circular economy is so compelling, why aren't companies already doing it? Now this is a very key point, that while we might know the theory of it, what do we see as our responsibility? Traditionally, a company did see its responsibility of producing good quality work and giving it to its customer, but slowly we need that change happening right from the beginning of the supply chain all the way to the way it is and the extended responsibility of the producer. And this change is part of the type of change which will come about through meetings such as this and the way people think, but also the incentive structures which they have going forward. Thank you.
Thank you, sir. Thank you. I would like to invite our next speaker, Padma Shri Dr. Ganpati Yadav. Dr. Yadav is an R.T. Modi Distinguished Fellow, and he is a J.C. Bose National Fellow too, and an adjunct professor at RMIT University in Melbourne. He holds a number of patents and is an elected fellow of such science academics as the Institution of Chemical Engineers, the World Academy of Sciences, and the Indian National Science Academy and the National Academy of Sciences. Introducing this Padma Shris is very hard. We can have a seminar introducing them only. Before I hand over it to Padma Shri Dr. G.D. Yadav. Over to you, sir.
Thank you, Samir. Thank you very much for this nice introduction. What I'm going to talk this evening is the role of green chemical sciences and engineering in the net zero target. Because I'm a scientist and done a lot of patenting, I would like to tell you something very different. So we all know the 17 goals of United Nations Sustainable Development, and they can be categorized into 6 different ways. And we understand this smart cities, sustainable cities and communities. Then we have this sustainable food, land, water and oceans. Health, well-being and demography, we know what it is. And very importantly, with reference to the so-called net zero economy, energy decarbonization and sustainability. So let me begin with this. So what is green chemistry and engineering? I can go on giving a lecture, but I'll summarize them. Any process which is safer, cleaner, greener, atom efficient, that means it reduces waste, sustainable, energy efficient, material efficient, so that reduces waste, environment friendly, and above all it has to be economical. Otherwise nobody is going to practice that process. So in the so-called sustainable development, we always have to deal with 3 different viewpoints. One is obviously the process has to be economic, it has to be environment friendly, and above all society must accept it. And there could be many different ways we can argue on this. So for example, people talk a lot about plastics and the so-called SUP. Remember the role of technology in restoration and sustainable development. The issues of waste management and sustainability are due to technological advancement. And plastic was introduced as a substitute for paper. That's a fact of matter. So what it means, if one technology creates a problem, another solves it. That is how human society has advanced. So in this new world, how do we, avoid wastage of both material and energy, and at the same time protect our environment? The hunt for new, smarter ways to support our development has always been a key driver of technological advancement. Today, as our civilization faces a new unprecedented challenge, technology can play a crucial role in decoupling development and environmental degradation. So, with this, we are talking about ecological restoration that again hinges on 3 different things. What is the theoretical framework for this restoration ecology? It may be soil science, hydrology and whatnot. And in the other way, you have the restoration restoration toolbox like the plant propagation technologies with modification of physical and chemical environment. And then you have the social system where the government will have the legislation and they will have many sorts of things. Mind you, the land use is one of the biggest problems for all of us. And because of the bad land management, it has led to drought, soil erosion, and desertification. We know that. And if you want to restore this ecosystem, chemical sciences will play a great role. Okay, so this is what I'm going to discuss about. Remember, in this figure, there are two contradicting things. On the left-hand side, we want to have things which need to be restored because we are already polluted. And on the right-hand side, there are means and ways of doing it. So the restoration can be done through smart engineering using green material chemistry and technology. So there is a solution for everything. As I mentioned earlier, one technology creates problem, another solves it. One of the important things which was discussed in a very interesting paper in Nature in 2019 was on the role of microorganisms and the climate change. Our activities and their effects on the climate and environment has caused unprecedented animal and plant extinctions. And we know that we have lost a lot of this biodiversity. And at the same time, these are very small, tiny creatures which are not seen by naked eyes. And there are something like 1,030 total bacteria and archaea. And therefore, the diversity of these microorganisms in maintaining sustainability and healthy global ecosystem is very, very important because that supports our life. So this particular picture which was published in Nature Review, is giving us a very interesting story. That is, we have all sorts of problems on land, under sea, in air, and we know this